Let's take a look at a few problems from section 5.4. The first problem that I have listed here for you is dealing with marginal cost and says the following. The marginal cost of manufacturing X yards of a certain fabric is C prime of X is equal to 3 minus 0.01X plus 0.000009 X squared in dollars per yards. Write an integral to find the increase in cost in dollars if the production level is raised from 2,000 to 4,000 yards. So the first thing that we need to talk about here quickly, or the first thing just to mention here, is that marginal cost is the derivative of the cost function, and that is sort of implied here. But that does mean that the cost function is going to be the integral of the marginal cost function, right? So for this problem, this is simply going to be the integral of 3 minus 0.01x plus 0.000009x squared. And we're just going to integrate from 2,000 to 4,000. All right. All right, so we have to actually find this integral. So let's go ahead and calculate. All right, so for this integral, we integrate 3 is equal to 3x. Remember, integrating a constant, we just add an x. All right, so for the next term, the integral of negative 0.01x is going to be negative 0.01x squared over 2, add 1 over add 1, the power rule of integration. And then finally, for the last piece here, integral of a coefficient times x squared is the coefficient times x cubed over 3. And then we're going to be evaluating from 2,000 to 4,000. All right. I will clean up my expression just ever so slightly to give 3x minus 0.005x squared plus 0.000003x cubed. And again, once we evaluate, we will plug in top minus plug in bottom. You'll definitely need your calculator here. But again, all we do is apply that fundamental theorem of calculus, plug in top minus plug in bottom. And here we get, I get 114,000. All right, one last problem for us to look at here. This problem, oops, scroll down just a little bit, kind of provides as a hint the average value of a function is defined as 1 over b minus a times the integral from a to b of f of x dx. So the problem wants us to find the average value for the given function. Well, the function is not given, but a graph is provided on the interval from 0 to 16. So I will say that our first job is, let's just go ahead and find, can we give a value for the integral from 0 to 16 for this function f of x dx? And we can do that by literally just calculating or using geometry to find the area between the graph and the x-axis. So I'm going to start by just, if I graph some area, first up I will have this little negative, let's call this area that will be tallied up as a negative value. We got this value right here. But we see really quickly, if we want to make it easy to calculate, that these two regions are going to cancel each other out, right? All right, so let's go ahead and continue to tally. So we have this positive region here and this positive region here. We got some more positive region over here, and over here. If we go, well, actually, yeah, we want to go all the way to 16, right? So, do note, though, that the x-axis here has an interval of 2. So let's quickly look at this. So if we look at, for instance, this little triangle right here, it has a base of 2, goes from 4 to 6, so a base of 2 and a height of 1. So this would have been a rectangle with an area of 2. So since we're only using half of it, we get an area of 1 right here. Similarly, right here, this rectangle would have had an area, so the complete rectangle, the 2 by 2 by 2 rectangle here would have an area of 4. So altogether, this has an area of 2. Each one of these squares has an area of 2. So all of these have an area of 2. This kind of counts as one unit that has an area of 2. And then finally, I have another half a square right here with an area of 1. All right, so if we add up, it looks like the total area here is equal to 15. So my integral value, well, not the total area, but the net area here has a value of 15. So now we can go ahead and find the average value. So the average value, remember, will be equal to 1 over 16 minus 0 times the integral from 0 to 16 for f of x dx. So this will be 1 over 16 times, we calculated the value of that integral, that is equal to 15. And so very simply, the average value will be equal to 15 over 16.